screenshots of these tasks on this file so that I can easily describe you what I am going to describe you. So first, in first task, I have described the time interval from 0, 0.01 to 1. We have taken the frequency is equal to 1. And you have seen we have to describe a signal. So here we take a signal, sine signal of, in this we use uh, f multiplied by 2 multiplied by 2 pi t. This is basically a sine signal. Now we have used plot. We have to use plot command to plot the output of the signal. Here we use one axis the time axis and the other one is the signal we have used the sine axis. So when we apply this input, the signal shown to us is the sinusoidal signal in between time and sinusoidal. The second task is to add the titles and x and y labels to the existing task. So as we know, in previous tasks we have used define the time from 0 to 0.01 to 1, and frequency was 1. Here is the same frequency 1, and the signal is the same signal that we have used in lab task 1. So first of all, we plot a signal t comma signal. So till this it is same like the task 1, but we have to add the titles and x labels and y labels to this task also. So to apply title, we use the command title plot of sine wave 1 hertz. This will plot the uh, title of the output, and in x label we use time in seconds and y label we use amplitude. Here we define the axis of x and y. Minus 0.05 to 1.5 is the axis of x-axis, and minus 1.5 to 1.5, as we can see in the output, minus 1.5 to 1.5, it is the interval of the y-axis amplitude. So when we apply this code in the command window, we see this output. We can see there is an interval of minus 0.1 to 1.5 in the x-axis and minus 1.5 to 1.5 y interval. And here we can see we have here plot of sine where the title is given and x amplitude, y amplitude title, and y x label title is also given. So the output of this is sine wave also in this given interval of time. Now moving towards task number 3. Again here we use two signals. So first of all, the time is the same as we have used the previous signal, and as there are two signals, so we use two frequencies. F1 is equal to 10 and F2 is equal to 520. As there are two signals, we use separately to differentiate them. We use signal 1 and signal 2, so we can differentiate among them. First signal F1 frequency 10, which will use frequency 10, and signal 2 F2 520 frequency will be used. First we define the signal 1 and 2. Now we have to plot a signal. As we know, the command of the plot is t signal 1. This will plot the signal 1, and we have to plot the same signal on the same graph. So again we use t along signal 2. So the time is the same, but the signal 1 and 2 will vary. And now we have to assign the title. As we can see the output plotting multiple signals in one finger, x level and y level. For axis we describe uh, we have described the limits and time interval from 0 to minus 1. Here we can see from 0 to 1, and in y 0 to 1. Oh, sorry, minus 1 to 1. This is the interval, and we have seen this the title and two signals are plotted on the same graph, and we have x level as well as y level. Now moving towards the lab task number 4. In this task again we have from the beginning we have in the same the time and frequency 1 and frequency 2, because two signals are taken. In signal 1 we have used frequency 1, and now we have to plot the signal in dots. So we have again used the plot command, but in addition with semicolon in dot. This will plot the signal, but in the form of dot. Hold on, and then signal 2 will again we will plot a signal 2, and signal 2 R commands means the dots will be happen, but in the red color. And again we give the title to the task and x label and y label, and axis as we know 0 to 1 in the x interval, and from -1 to 1 in the y interval. Here we can see the output. We have red and blue signals. The red one, the signals are the signal 2, and the uh, blue ones are the of signal 1, as we have discussed in the code. Now moving towards lab task number 5. So in this task we have used the commits also. As we know that many codes we have to use this commit section, so that the other users who uses the code easily can understand what we have discussed in the code. So in this task we have used the commits. For the commits we use it as percentage sign, and after the percentage we what we light over here, it is in the commits. It is not the part of this part of the code, but basically it will help the user to understand what is happening in the code. First we have used written over here generate random data from a uniform distribution, and then again percentage and calculate the mean, plot the data and the mean. From here we can see what is happening in the code. We are taking the random number and taking the mean and then plotting the data and mean. So here n is equal to 50. Again percentage sign, we have given a comment here that 50 data points are here. Now random. Random number we assign from n is equal to n 50 to 1. Plot command will assign plot the our signal, and mean we have taken the mean is the average, also we can also call average of the signal. Okay, now we have to define the limits of interval from where to where we have to plot. Draw a line from 0 to m, and here is the command, and for this to implement we use the command plot 0 to n comma m to m, and hold off that for the, and in the last we have used the title, so which appear in the top of the graph. Title is the mean of random uniform data. From the output, we've seen that the mean of the signal, the random signal, is at point below point 0.5, is a straight line in the constant straight line. This is the mean of the random signal. Okay. Now moving toward lab task number 6. Now basically task number 6 from onwards till I think so 11 or 12. These are tasks are uses a function. Function basically first we make a function and save in this our MATLAB on our computer. Again, then we have to set the function. We just call the function and easily implement the data. So here we can see that function, and we have created a function max element, min element, and we have named this as my function x, and maximum element is equal to maximum of x, and minimum element is equal to minimum of x, and then end of this command. First we have plotted this describe this function and save in this by the name of my function dot n. Now in the command window, just I have to use the big small my function, call my function, and this is the array from where we have to find the big and small element. As we use the my function command, it will go to this function and check what is in this function, and it will first show us the big element, which is 55 over here, and then minimal element, which is 3. We are not, we will not write anything else, just we have to call the function and give our array. Now lab task number 7. In this task we have also used function of my main name. In this task we are interested to find the minimum element from the array. First we describe the function over here. Function of main is equal to my main of x, and first we set the minimum value x of 1, and we start the loop for loop from first element to up to an element of the array. If we find any element of in the array less than the first element, we will replace it with that element and store it in the main value. This loop will work until it computes. It will reach the last element, and we will find the minimum element. We will set this function, and we will store the function within the name my main. Now we have used this array x is equal to 37529, and we just call my main function. When we call the function, we just get the output our 2 here, which is the minimum element in this array. We do not need to describe anything else, but just we have to call our function. Now moving towards function max 8 lab task number 8. Here we will find the maximum element. It is same as the previous task, just it is different that first we set the first element is equal to maximum, and again we start the loop and check it's the loop check if an element is greater than first element. If so it will replace it in the maximum value. This loop will continue till the end of element and store the maximum value in the max, and this loop function will complete. Again, we describe this our array and just call m is equal to my function x. Here it will this law will work, and like as we know 9 is the biggest element in this, the maximum value will be displayed to our command window. Now we have to find the average of the array. It is again we use a function, we name it my average. N is equal to length of the x. As we know, the average is equal to sum of all the elements divided by number of elements. So first we describe the n is equal to ln of x, length of x, and we sum all of the element in the array and store it in sum of x. Now we take the average. We know sum divided by total number of elements. This will the formula, and we will save this function as my average. Now we use the array in the command window and just call my average. So it will implement the whole process and will give a sum and average of this array. Now lab task number 10. Here it is simple task. We have to sort our array. We use the function sorted and name is my sort of x, and sorted is equal to sorted of x, and then store this in the MATLAB computer, and then just in the command window we use array x is equal to 37529 and call the function my sort of x. Here this function will be sorted and will be displayed to us 23579. Now lab task number 11. In this task we have to reverse our array. We use the function reverse and name it my reverse, and again uses the reverse x and minus 1 to 1, and this will reverse our array. As we know this is our array and we just call the function my reverse. It will give output 92573. It will reverse our array. Now lab task number 12. Here we are interested in two signal to plot subplot two signal. Here the time is the same. X is a random signal from 50 to 1, and Y is sinusoidal signal 10 to pi t. And we have to plot these two signals. So X subplot 1 to 1. This will plot x, and again subplot 1 to 2. As we know, we have used the plot command. It will plot two figure on the same two graph on the same panel. Now moving toward the final task, which is lab task number 4, we are interested to draw the fourth subplot uh, of 2-2. Here we can use it anything else 1-4 or 4-1, but we have used the 2-2. 2 is the row, 2 and 2 is the column, and 1. This is a 1. Again the 2-2 and 2 and 3 and 4. If we use the 2-1, 2-4, something else, it will be displayed this output. So by this our 13 task score completed, and meet you in the next video. Further stay tuned, press the bell icon and to support us. Thank you.